All right. Example 2 takes the product rule to a higher level. Okay, because notice I've got x squared being multiplied by secant of x being multiplied by tangent of x. All right. That is uglier than x squared sine of x. Not because secant and tangent are there, but because we have function 1, we have function 2, and we have function 3. Product rule has a rule for 2 functions, not for 3 functions. So here's how you do it. This is a pick your poison moment here. You ever heard that term, pick your poison?
Mm-hmm.
And you got 2 bad options. Which one do you want to take?
I want the really bad one.
I'm going to say that's function 1, that's function 2. Okay?
Pick your battles.
Oh yeah,
Right.
That's a good one.
So function 1, function 2 here, okay? So if I do y prime equals, now I'm supposed to do 1d2, right? So again, this is function 1, this is function 2. Okay, let's imagine d2 real quick before I start writing it down. What type of function is d2? Or, sorry, what type of structure is function 2 here? Is it a polynomial? Is it a product quotient? It's a product, okay? So function 2 is a product, so to find the derivative of 2, we have to do the product rule, right? So to do d2, I've got to have a function 1 and a function 2, right? So looking at d2, I've got to do 1d2 plus 2d1 for that piece, right? So just if we imagine d2 right here, I'll just put it in this little box here, hope it fits. All right, so if I do 1d2, I'm going to get secant of x times secant squared of x. That's 1d2. Plus 2d1 is going to be tangent of x times d1, which is going to be secant of x tangent of x. Alright, so when you have a product involving more than 2 things, one of the derivatives you're going to have to do is going to require a product rule. So I might recommend coming to a separate page over here, figuring out its derivative, and then you can put it back in there. So this right here simplifies to secant cubed x. And this right here simplifies to secant of x tangent squared of x. Secant first, secant squared, 1 plus 2 makes 3. Tangent, tangent, 1 plus 1 makes 2. So we're multiplying common bases, we add the powers. Basic algebra there. So this is d2 right here. So now when I do 1d2, d2 is secant cubed x plus secant of x tangent squared of x plus because the rule tells me to do plus, right? 1d2 plus 2d1. And then plus 2d1 is going to be secant of x tangent of x. d1 is going to be times 2x. Alright, so again, you always, if you're going to use the product rule, you have to identify this is function 1, this is function 2. When you differentiate, you have to ask yourself, how do I differentiate this function? This function has a product structure, so I have to use a product rule to differentiate that structure. This is a polynomial structure, x squared, I have to differentiate that by the power rule, 2x. Alright? I could have just as easily put x squared secant of x as the first term, tangent of x as the second term, done the same thing, we would have got the same answer. It doesn't matter how you do it, you're going to get the answer because the derivative is what it is. Alright? Sometimes with trigonometry, based on trigonometric identity simplification, you might have 2 answers that are the same that look different. Okay, so it might not look exactly the same, but they'd be the same answer. They'd be equivalent. In this case, I think they would be exactly the same. I'm not going to try it out though. So y prime equals. So x squared times this sum, so I'm going to get x squared secant cubed of x plus x squared secant of x tangent squared x plus 2x secant of x tangent of x. No like terms, can't make it any prettier than that, so that is the answer. Unfortunately, that is the most efficient way to do that problem. There's no easier way to do it. The definition derivative, the limit of f of x plus h minus f of x over h, that would be pleasant on that one there. It would be pretty rough. So anyway, that is the best way to do it. And focus on structure. What rule do I need to use for that structure? Those types of questions need to be entering your mind as you're doing these problems.